Good morning, my dear students. This is the second problem in the discrete random variable which we are going to discuss now. Okay, so the second problem in this, already you might have watched the first problem in the discrete random variable. This is the second problem. Just to recall, in discrete type random variable, there is just one simple condition that which you need to remember. That is probability of x equal to xi is equal to 1. So when you add all the probabilities, the value is 1. That's the only thing which you need to know. With this information, we need to calculate, we need to find the probability function itself, probability mass function or probability distribution. Here the problem is that, unlike in the previous problem, we were given the distribution x equal to so and so. This is p of x, all those things. Here, if you notice, they didn't give that this thing. What is it? The probability table. Instead, they have given some information. The information is what are all the possible values of x's? 1, 2, 3, 4, and then it satisfies this probabilities. All these things satisfies like this. Okay. So now let me write it here. Given that, what is given to me, let me write it here first of all. Given that x stands for 0, 0, 0 is not included, 1, 2, 3, and 4. There are only 4 values in this x. The aim of this problem is I have to find probability of x equal to x. Okay, or I'll write it as just a p of x. P of x, okay, so this is the p of x, like this. Okay, say in this probability, it will be continuous, the notations will be continuously abused. Sometimes I will use probability of xi, probability of x equal to x, or probability of small x. Everything denotes that is probability of x equal to x. X equal to x means identically like this. Probability of capital X equal to small x. Okay, like this. This is the ideal situation. Now, I have to find this value. What is it I have to find this value? It says, what is the value at probability x equal to 1? These are the values I need to find it. So now, given, okay, so what is further given that if you notice in the question, some information were given. So what does it means? 2 times probability of x equal to 1 is equal to 3 times probability of x equal to 2 equal to equal to probability of x equal to 3, like this. This is given to us. I'm going to take it as, okay, I'm going to keep the name, let probability of x equal to 3 is equal to k. Why did I take, I'm taking k as some constant. You can name it. You can name it as b, a, anything. Okay, so why did I choose this one instead of not probability of x equal to 1? Okay, see, you are free to choose anything. But what is it, the convenience for choosing some value for probability of x equal to 3 is, notice that there is no coefficient in front, no number in front of x equal to 3. That's the reason I chose like this, probability of x equal to 3 equal to k. So now, what is it we are having here is, the value I have chosen here is k, right? And rest of the values, in terms of k, what is it we will see. So now, see the further, the highlighted one, this probability of x equal to 1 is equal to probability of x equal to 3, isn't it? So this is given to us. So now I'll write it, whatever I showed it in the highlighter, I'll write it like this. It implies probability of 2 times probability of x equal to 1 is equal to probability of x equal to 3. But I have called this probability of x equal to 3 as k, isn't it? So what I will do here is I'll replace this probability of x equal to 3 as k. Okay, so this is the one I'm going to replace. This is equal to k. Okay, I have replaced it with k. So now, what is probability of x equal to 1? It is a child's play. you will divide it by 2 both sides. It is k by 2. So what does it mean? This 2 cancels. Probability of x equal to 1 is k by 2. So let me substitute here k by 2. Okay, so then I rub this now, it's not required. Now similarly, you will have to find here what is probability of x equal to 2. Probability of x equal to 2, needless to say, what does it mean? K by 3. The reason is 3 times probability of x equal to 2 is equal to k. What is probability of x equal to 2? Then it is equal to k by 3. Okay. Next is this one. You would have guessed it. Yes, it is k by 5. Right? I'll write all those things. How did I get it? So I'll write here 3 times probability of x equal to 3, x equal to 2 is equal to k. So that implies, what is it implies to me further is, what is it? Probability of x equal to 2 is equal to k, k by 3. Let me write this properly, k by 3. And probability of x equal to 4, I'm writing it directly, k by 5. The explanation, if you want to see it, it's a similar to previous information. Now you are having a table. Now it becomes as a previous problem. There is absolutely nothing for you to think about now. Now see the table. You are having this table. Okay, this is the one. You find the value of k. The problem is done. So let me find the value of k. How to find this value of k is, I will write it as we know that. I will assume you also know that. Okay, we know that. What do we know here is summation probability of x equal to x or p of x equal to, when I add all the probabilities, that's equal to 1. Its meaning is k by 2 plus k by 3 plus k by 5 is equal to 1. So I want only the k value. So what do I want here is k into 1 by 2 plus 1 by 3 plus 1 plus 1 by 5 is equal to 1. Okay, so now use this. If you want, you can use the calculator or you can use directly. Okay, so what I'll do here is, okay, so otherwise, I recommend to do this directly. So let k equal to k into this total value is 15 into 30. Okay, so this is what I'm having, 15 into 30. So now here it is 15 plus 10 plus 10 plus 30 plus 6. So if you count this, the numerator, it's just a basic LCM. You can use your calculator to do this. Okay. So this implies 40, 55, 61. So k into 61 by 30 is equal to 1. I want only the k value. So k value is equal to, it implies k value is equal to 30 divided by 61. So this is the k value you are done with. So now substitute, you will get the probability mass function. So what is the probability mass function is? This is the one. Okay, I have to substitute where I will have a k. Let me copy it and take it for you. So Control C and paste it here. So this is what I'm having. So I have pasted here. So when I substitute here k value, so this is the k value. K value is 30 by 61. So when I substitute 30 by 61, I'll get 15 by 61. Okay, so it is just you check it. Okay, 15 by 61. Now k by 3. K by 3. It is 10 by 61. I don't want to write it in decimal. You know that. Why? So next, when I change here, it's 30 by 61. Here I had 5, I think so. What is it? K by 5. K by 5 means it is which I'm having 30. 6 by 61. Okay, so this is what I'm having. 55, 55, 61. Okay, so this is the distribution function. Okay, so this is the probability mass function. Now, if I wanted, what do I want here is, I want the second problem in this is, if you notice, I want the cumulative distribution function. Let me copy this snippet to the next page. Okay, so I want the cumulative distribution function. Okay, the second problem in this is the cumulative distribution function. Let me keep it here. We call it as cumulative distribution function. The cumulative distribution function. What is the cumulative distribution function here is, I will call by the word f of x is equal to capital F of x. I will use its probability of x less than or equal to x. So what is it am I going to do here is x equal to 1, 2, 3 and 4. Okay, I will give you a shortcut rather than employing the definition as f of x. See, this one I bought it from the previous page, isn't it? So what is it you will do here is, in the same thing, the first value you will write the same. The capital F of x, the first value will write same, 15 by 61. Now this value is this plus this. Okay, this plus this. 15 by 61 plus 10 by 61. So it is 25 by 61. Next, if I want the value here, this plus this. Okay, so like this, we add and keep on adding and going. Okay, so I'll repeat here. I'm going to write it here. So what does it mean? The first value is 15 by 61. I wrote it. Okay, the first value, whatever it is here, whatever that is, let me wrap this. See here, the first value from the P of x, I take it and put there. Okay. Next, what happens here is, the second value, what will it become here is, I will take this 10 by 61 next plus the before. What is this value? 15 by 61. The before means this value. So 10 by 61. So I will get it as 25 by 61. You just calculate it. I will write it here. 25 by 61. And next is 25 plus this one. It's 55 by 61. The last value will be 61 by 61. That's equal to 1. Okay. So this ends the cumulative distribution table. There is nothing else. It is in this. It's a very simple actually. Okay. Now this problem is also done. Let us go to the next problem. What is the next problem here is find probability of x less than or equal to 3 given that x more than 1. Okay, so like this we have. So let me write here probability of the third one is find probability of x less than or equal to x less than or equal to 3 given that x less than or equal to 3 given that x more than 1, like this we have. So it's a very simple. Use this A given B. Probability of A given B. A given B is equal to probability of A intersection B divided by probability of B. Okay, employ this rule. Nothing more than this. When I employ this rule, what happens here is directly A is, what is our A? Probability. First you write the probability. I wrote this probability. A, x less than or equal to 3. Intersection x more than 1. Okay, like this we have. X less than or equal to 3, intersection x more than 1. Okay, so now this rule is not required. Let me delete this rule. Okay, so this is gone. X more than 1. So now I want this, the intersection x more than less than or equal to 3. Let me use this in a small graph. Okay. It is just a rough graph is enough. Okay, so for you to see, let me choose this. This is x. Okay, sorry, this is y-axis, and then so this is what I'm having. Now, this side is a positive 1, 2, and 3. This side it's a minus 1, and here it is 0. Okay, minus 1, minus 2. This is for x. Okay, x less than or equal to 3. So x less than or equal to 3. Okay, x is 3. Where is x equal to 3? Yes. I will use the red line for x is equal to 3. Okay, so this is where x equal to 3. Draw a very big line. So this is I will choose another color. I will use red. So this is the one x equal to 3. Okay. From x equal to 3, what happens here is I want less than 3. Here what is the symbol? Less than or equal to 3. Less than or equal to 3 means it goes this side fully. Okay, it goes fully this side. Entirely it goes until minus infinity. Don't assume anything that this is stop. Okay, so it goes fully, and 3 is also included. Okay, it doesn't stop. Now the second value, x more than 1. What is the number? 1, right? So go take your ruler to 1. I have taken this ruler to 1. Okay, so I will use that green. Okay, so I have taken this ruler to 1. So now, here 1 is not included. Okay, here 1 is not included. When 1 is not included, there 3 is included. Okay, so what does it means? I will, one thing what I have to do here is, it's divided by probability of x more than 1 as per the rule, right? I forgot to write. Okay, so just remember. Now, x more than 1. X more than 1. X more than 1 means, let me continue with this. X more than 1. This side, but 1 is not included. Just remember, 1 is not included. Okay, so like this it is it. Now, where do you have both the green lines and that is intersection? Green line means like this. Where do you have, I will draw differently these green lines. What does it tell you here is, I will use a highlighter. Not highlighter, not required. So you just see, where is the green line? It's more than 1 means like this. Okay, so now, from where is the green line, the intersection of the green line and the red line? I hope so, you'll accept, this is the highlighted area only. We have everything. Okay, so that highlighted area is 1 to 3, isn't it? So with this explanation, okay, so I'll rub everything. Just look at for once, and okay, so this is the highlighted area which I'm getting. So now the numerator, what it happens here is, the numerator, the denominator is same. There is no change in the denominator. Probability of x more than 1. But the numerator, what it happens here is, when I showed it in the graph, it is, the intersection area is 1 less than x less than or equal to 3. Here I have taken only less than, strictly less than. Here I have used inequality. It depends here. See here 3 is included, 1 is excluded. It comes from, okay? So try to understand this. Now this problem is very simple. So now what does it mean? I need to have the table. Okay, let me bring the probability table. This is the probability table. So this is the probability table. what is it I'm having here is, let me break it here. Control C. This is the probability table which I'm having. From numerator, what is the numerator I want here is, what is the numerator is, starting from 1, but 1 is omitted and 3 is included. So here, if I see, starting from 1, okay, but 1 is omitted, next to 1 is nothing but 2 is remaining. So if you notice, only this is the value. So what it happens here is, I can write it as the numerator as 10 by 61 plus 30 divided by 61. Denominator. What is denominator is x more than 1. X more than 1. What are all the numbers more than 1? 2, 3, 4. So just add those probabilities, 2, 3 and 4. So it is nothing but 10 by 61 plus 30 by 61 plus 6 by 61. Okay, so what is the answer you are getting? Let me find it out. So here it is 40, numerator it is 40, here 46, 40 by 46. Okay, this is what we get. The answer is that. So the conditional probability, you try to understand it slowly. A small basic diagram is enough. You will have to find the intersection point. Okay, so now we are left with the mean and the variance. Mean and the variance, my students should be well aware of this. Okay, so let me now mean and variance. What is the mean and the variance here is? The first of all, let us say mean. Mean is equal to expectation of x. What is the expectation of x is? If it is a discrete, summation of x into probability of x equal to x. So what does it tells you here? Again, I require only that which one? The probability mass function. This one, what it tells here is x. What is the x value? 1. And multiply it with this corresponding probability. So that's what. See the yellow highlighter, what it is? 1 multiply 15 by 61. Do you understand this? Next is, since there is a summation, you need to put plus. Now I will highlight with then what is the next number? 2 multiply 2. The next number is 2. Multiply with this probability 10 by 61. And next number is 3. 3 multiply 30 by 61. Okay, next 4 multiply 6 by 61. Okay, just calculate it. Okay, so again I'll require this. Okay, so but I'll delete it now, this value. Okay, so now what does it mean? You are having this is equal to let me write it 15 by 61, 15 plus 20, how much I'm just calculating, 24 plus 90. Okay, so I will use the calculator. 24 plus 90 plus 20, okay, plus 15. Okay, this is what I'm having, plus 15, I hope so. It's a 149 by 61. 149 by 61. To calculate the variance, I require one more thing, something called as E of x squared. What is the expectation of x squared? See, I'm going to change only in this one. I will just copy and bring it for you. See, whatever you are having E of x, isn't it? So just copy and bring it. Control C and Control V. See here, I have copied and brought it from the E of x only. The same thing. Okay, here 6 was there, it wasn't copied. Same thing only. Only one change. What is the change here is, x alone should be squared. Square this x. Be clear? See, I have written in red. Just square this x. That's it. But don't square the probability. This is the common mistake made by the students. Okay, so now it is, what do we get here is, whatever is it, using the calculator, you do it. So now what is it containing? Let me check. It is 51, 15 in the numerator. Next 40 plus 9, 270. Next plus 16 into 6. Okay, so what does it mean? Plus 16 multiply 6. Okay, so this is what we are having. So it is 421 by 61. So the answer is 421 by 61. Okay, finally, the variance of x. We will denote it as VAR. It is E of x squared minus E of x, the whole square. So it is 421 by 61 minus 149 by 61 without forgetting square. Okay, this is the square of that. So let me use it. So what I will do here is 421 divided by 61 minus where I have 149 divided by 61. Now close the bracket, whole square. Okay, so this is what I get it. So answer is 0.935, or whichever it is, you can write. So 0.935, that's it. 0.935. Okay, this is the end of the problem. 0.935. So practice this problem, and then what is it I want to do here is, I will just give an explanation to the physical students here. This problem. Okay, let the next problem, let me check whether I have interest. Okay, so I will pause this video. Okay, this is the problem I want you to try. Here, the probability mass function or whatever it is given in a different manner. Let me write it here. I will use this one, either this one or this one. Both are same. Instead of small x, they have used it as j. Okay. So now let me use this solution given probability of x equal to x is equal to 1 by 2 power x. 1 by 2 power x. X equal to 1, 2, 3, and so on, infinity. Okay, this is what we are given. X is defined at 1, 2, 3, and so on, infinity. First of all, is this a what is it? Is it a discrete or continuous? The question, if it is discrete or continuous, means don't think that for continuous there are infinite, for discrete there will be finite. Because in the previous two problems, what did we assume was all the values had n values, but here it is going until infinity. But what it is, if you notice here, it is countable 1, 2, 3. So it is countably infinite, we can call it. So this is a discrete because between 1 to 2 itself there is infinite number of points. It doesn't take. Okay, we have a countable number. So this is called as a discrete type random variable. So for the discrete type random variable, what all I want here is the mean and the variance. What I will do here is, I will do the this one. That is probability of x is even, something like that. Okay. So the only one I will take it. I'm not sure whether do we have this moment generating function. Let me check this. Check the outcomes and then I'll come back to you. So what is it you will do here is only one I'm going to do. Rest of them you will do it as homework. Okay. So now in the solution, what is it I'm doing here is the second one. Probability of X is even. What are all the even numbers? Probability, what are all the even numbers? Probability of X equal to 2. This is the first even number. Okay, X equal to, what is it? X equal to 4, okay, plus X equal to 6, and so on. Okay, it goes on like this. Now in the definition, see here, in the definition, this is what is the definition. X equal to 2. Just go and change in this, the yellow highlighted 2, that small x equal to 2. Okay. So now when I change it, when I substitute, what would I get here is 1 by 2 the whole square, isn't it? See here, only at this place it will change, x equal to the square. The next is plus x equal to 4, 1 by 2 to the power 4. 1 by 2 to the power 6 plus 1 by 2 to the power 8 and so on. Okay. Now, how to sum it up this? Because I have an infinite number of values. So what is it you will do here is, you will take it up 1 by 2 squared outside. Always try to take up the first term fully. When I take the first term fully, I will have here 1. 1 by 2 squared is taken. Here, 1 by 2 power 4 is there. So how much will I have? 1 by 2 square. Okay, here 2 power 6. So it is 2 power 3 plus and so on. Okay. I will rewrite this again. 1 by 2 squared is 1 by 4. But here I wouldn't simplify like this. 1 by, that is, what is it we are having? 1 by 2 squared. Like this we have. I think so. It would have been better. 1 by 2 cube we are having 1 plus x squared 2 power 3. Okay, so did I do it properly? X squared power 4 power 6. Okay. So what does it mean? I'm having 1 by 2 the whole square and 1 by 2 the whole cube. All those things which we are having. So how are you going to do this? Any idea? So you might have remembered there is a series. What is the series here is 1 plus x squared plus and so on. What is it? 1 minus, that is equal to 1 minus x the whole power minus 1. Isn't it? Similarly, 1 plus 2x plus 3x squared plus and so on, that is equal to 1 minus x whole power minus 2. Right? Like this it goes on. Right? Okay, so what is it we will do here is, instead of taking that 1 by 2 squared and all those things, there is some convenient way. What is it we could have done here is, instead of taking this, it should fit to one of the series like this. Okay, one of the series means the series which I have mentioned here, 1 plus x squared. So what I will do here is, I will put here plus 1, I will add plus 1 and subtract 1. Isn't it? There is no loss in generality. See here, I put 1 and at last I added 1 and subtracted 1. So there is no loss in generality in doing like this. Now if you see 1 by 1 plus, inside the bracket I am talking, 1 by 4, the first one, 2 squared. Here, what is it I am having here is 1 by 2 squared I am having. I can write it as 1 by 2 squared the whole square, isn't it? So, 2 squared the whole square, 2 to the power 4. Next here, 1 by 2 squared the whole power 3. Plus and so on. And at last that is minus 1. Right? So this is 1 plus 1 by 4 plus 1 by 4 the whole squared plus 1 by 4 the whole cube plus and so on. and there's minus 1, there is no loss in generality. But see here, this 2 series, 1, 1. Next, here it is x. So here it is x, here it is 1 by 4. X squared, 1 by 4, the whole square. So if this series goes, this is the answer, 1 minus x, the whole inverse. Okay. So instead of that, what is it we can do here is, okay, instead of this infinite series, I can write it as 1 minus x. X is 1 by 4 here, the whole inverse. This minus 1 comes from here. Okay, so this is what I'm writing, the minus 1 from there. Okay, so this is minus 1. Clear? So this is equal to, that's it. The problem is done. So what is it you will do here is, you will integrate this. So you will calculate this. The calculation of this is 1 minus, let me write it properly here. So it is, the calculation of this is 4 minus 1 divided by 4 minus 1 divided by 4, the whole inverse minus 1. So 3 by 4, the whole inverse. So 3 by 4 means 4 by 3. Okay, 4 by 3 minus 1. Okay, 4 by 3 minus 1. So what is the answer? You will get 1 by 3. Right, 4 minus 3 is 1. So it is 1 by 3. Okay, this is the answer. Like this, try to do all the problems. Okay, and let me know. This one I need to check the moment generating function is within the scope of the outcomes or not. I'll check it and let you know. But you try rest of the problems. That's it for this class, my dear students. Thank you.